years now. It is called Cytomine. So when we started this project, the goal was really to develop a software that will ease the collaboration between pathologists, biomedical researchers, and computer scientists. So this software is fully open source and available to everyone, and I will present you its main features to you. So when we started this project, we realized when discussing with pathologists and biomedical researchers that they spend a lot of time looking at their images and performing semantic annotation and quantification of these images. So they want to quantify different types of cells, they want to quantify the area, different types of measurement of their tissues, they want to count cells, etc. But what we realize is that still these work are performed quite often manually, so it takes a lot of time to them, and the fact that it's done manually also limits the number of images and the number of cases they can analyze. So their studies might be sometimes limited in terms of statistical power. Also, what we realize is that they are often working in an isolated environment, so that they store images and they store their results locally, sometimes on their hard drives. And often these results, these images are somehow lost because of this local storage. And also we realize that they are working with proprietary software and proprietary formats, which makes the reuse of this data quite difficult. So, as I said, the objective of this project was really to make life easier for pathologists, life scientists, and importantly the computer scientists who need these images, who need this run-through data to work. So this software has been developed continuously since 2010. It's an academic project with collaborators that are pathologists and biomedical researchers, but we followed quite proven standard in software development, so we believe our software now has reached some quite good quality. It's a general purpose software. We started to work on it, motivated by some application in lung cancer, but this is not specific to lung cancer, and I will show you several applications in different fields. It's a web-based software, which means that everything is accessible from the web. It implements Google Maps like visualization of digital slides. It implements tools to collaborate and annotate images from everywhere. It implements some algorithm to analyze this data, and very importantly, it's very extensible. So, of course, our algorithms are not solving all the tasks in pathology and biomedical research, and the idea was to provide a toolbox so that other researchers can implement their own algorithm. We also implement secure protocols to share images, annotation, and results with your colleagues. And very importantly, it's open source software, so that means that everything is accessible. You can understand deeply what the software is doing, and you can extend it. So the main philosophy of the software is that once people generate images, they can directly upload their images, their whole slide images, into the Cytomine server. And so the images are directly accessible to everyone in the world through simple URLs. It means that several people can annotate these images, so you can have several pathologists, several biomedical researchers looking at these images and annotate them, so that they can build run-through data. In this example, you have samples of tumor data, tumor tissue regions, and non-tumor regions. And all these data, all these annotations are exportable, so you can reuse them in other software. And, for example, you can implement algorithms that will access this run-through data, run these algorithms on remote servers, apply this algorithm, And the result of this algorithm can be analyzed by experts through the web, so that finally they can export their data in standard format to exploit this. So that's really a simplified view of the software and how you can use it. You can have several database servers, you can have several computing servers, etc. So I will briefly go through some of the main features of the software. So it is important for biomedical researchers and pathologists to organize their data. And so what we have is the concept of project. So each of the boxes you see here is a project in which people can upload their images and give access to their colleagues. So for each of the projects you define the colleagues that have access to it. You define the type of images that you upload in this project. And you define a concept that is the ontology that I will describe afterwards. So as I said, the software allows you to visualize very large images that are produced by the digital scanners. So you have here the main explore view of the software. So you see here the thumbnail of the image, and you can zoom in and zoom out in the image, and only the parts of the images that are visualized are transferred through the network. And so we support very large images. There is no theoretical limitation to the size of these images that you can transfer through the web. Okay, so it's not only about visualization, of course, it's also about annotation of these images. So we have implemented different drawing tools. So directly in the web interface, the pathologists, the biomedical researcher can draw first manually different types of objects, geometrical objects. So you see here that I have annotated some tumors, some bronchus, etc. So you have here examples of all the bronchus that I have annotated in the images. And to each of these objects, to each of these annotations, they can assign different types of information. One of the information is the ontology terms. So it's possible to define directly on the web interface an ontology. So this is basically a vocabulary of terms that each of the pathologists can define for his project. And so it's a list of objects that they can visualize in their images. And so at the end, the colors correspond to the different terms from the ontology. And so, yeah.
Is it based ontology for that, or is that also used?
No, it's a user-defined ontology. So for each project, it's possible to define the ontology. But as I will explain, the core software is very open, so that you can imagine to have an external ontology and import it in the software. Yeah.
Can you have a hierarchy of ontologies? You say this one also always has to contain this and this.
So the only hierarchy that we have is relationship of parent and child. So here you have the tumor type and you have subtypes of tumors. It's the only relation that we have defined up to now. And so what people can do with this is to annotate large sets of images and build ground truth data for people working in machine learning. So for example, here you have different types of cells that have been bone marrow cells that have been annotated by some experts, and you can easily visualize galleries of this annotation and easily export this annotation for machine learning. And you can do it in a collaborative way, so that different types of collaborative modes, so that people can together annotate the same annotation. So there is also a blind mode, so that different pathologists do not see the work of other pathologists. We have implemented a content-based retrieval algorithm that we have published before, so that each time an expert annotates an object, like the cell here, there will be an online algorithm that will look into the database for similar annotations based on the visual appearance of this object. So it's gives you in almost real time other examples of cells that look similar for the algorithm. Of course, it's an algorithm that is not perfect. You see here some example of wrong suggestions, but overall it's provide good performances. What is very important with this software is that every piece of data is you can share it. So you can share the images, you can share the annotations through simple links. So for example, you can annotate an object in an image like this. You can send it send a link directly from the web interface to your colleague so that it got an email, and in this email there will be a link that he or she can click on and directly jump into the region of interest in the image. So it really is the annotation and sharing of this data. Another nice features that is appreciated by pathologists but also by other type of user is the live broadcast. So you can have one user, which I would say is the master, and you can have several other users. So in this case, user A is the master, and you can have several user B that will follow user A. So each time this user is moving or is drawing an annotation in an image, the information is sent to all the followers, so that the screen of the followers is also moving and display the annotation of the users. So you can do it from anywhere in the world. Each user can be at any place. And so it avoids the old school way of sending digital slides by snail mail. We have implemented a few machine learning algorithms for different types of tasks. For tissue segmentation first, so we have applied it to several problems, but mostly to lung cancer recognition in animal models. We have implemented landmark detection algorithm, and we have also implemented object classification algorithm that we have applied to cervical cancer screening and also to glomeruli detection in renal biopsies. But of course, all these algorithms are not solving all the problems in pathology. So we put a lot of efforts to make the software open and extensible. So, as I already said, every piece of data is accessible through HTTP request. So it's more technical slide, but briefly, you can access, for example, the list of all the projects, or you can filter the annotation that have been drawn by certain user in a given project and a certain type of annotation. So you can really export all the data from this software. And it's also, here you have examples. It's easy to export an image area. You ask the coordinate image area from these coordinates and from this size, and you get this type of result. So you can really export images, annotation and annotation mask using the web services. Our API has been extensively documented, and you can access this documentation. And to ease the work of computer scientists and data scientists by informaticians, we have also implemented Java and Python clients, so that this client directly access the API, so you do not have to rewrite access functions. And you can also plug your own software. So you define your software, you give it a name, you give it its parameter types, parameter values, and then you can reuse our previously designed user interface. So for example, let's imagine that you have an object classification algorithm using a certain flavor of deep learning. You can register the algorithm, and then you can reuse our user interface. For example, this user interface allows you to visualize confusion matrix to see how well your algorithm is performing. And we have also a proofreading interface, so that if your algorithm is not correctly classifying object, you can drag and drop this classification and correct this classification using the user interface. So all these user interfaces are not linked to a specific software, they are generic, so you can reuse them, and that's the same here if you have an algorithm that generates segmentation mask. Like in this application we worked on, the goal is to segment tumors. You can imagine to plug your own segmentation algorithm using some codes, and then it will appear directly in the user interface. You can select your algorithm, you can visualize the segmentation mask that has been produced by this algorithm, and you can use our proofreading interface so that you can correct this segmentation mask. It's the same for the user interface, you can extend it easily. I will skip this. The software is fully documented, and we have applied it to a large range of problems in lung cancer, breast cancer, thyroid and cervical cytology, renal biopsies, etc. So to summarize, Cytomine is free and open source. You can reuse it and download it and modify it as you want. It has been designed with general methodologies. We believe it will foster collaboration between life scientists, pathologists, and different types of computer scientists. It's of course not universal, but we already have applied it to a large range of applications, and it's fully extensible. And we are very open to collaboration with academic research labs, but also industrial projects. And in the future we will have a kind of structure to coordinate the development efforts of this project. With this, I would like to thank my colleagues and sponsors of this project.